Hello and welcome to day 7 of this bridge course, 9th standard to 10th standard. In this video, we will be talking about surface areas and volumes. Surface areas and volumes is very important in 10th standard. I know you must be thinking that everything I say is very important. That is not necessarily true, but in this case of surface area and volumes, you have exactly the same chapter, well, at least the same name in 10th standard, and it is a place where you can easily score marks if you know how to how to solve some of the problems. But to solve some of the problems, you should understand shapes and you should understand formula, and you should be able to know the difference between areas and volumes, surface areas, curved surface areas, lateral surface areas, and total surface areas. Okay, so what we will do today is basically, I'll just quickly touch upon areas and volumes. Area is basically the space occupied in a two-dimensional object. Area is two-dimensional, so let us say you have a square 1 centimeters by 1 centimeter. The area is 1 centimeter square. The cube is the volume is three-dimensional. So if you have a cube which has 1 by 1 by 1 centimeters side, the volume is 1 into 1 into 1. The unit, if you look at it, because you multiply 3 times, it'll be centimeter cube instead of centimeter square. Whereas in the case of a square, it was just 1 centimeter square. So you have to be very careful about the units. So the length, if you're talking about the length is unit is 1 centimeter or 1 meter or 1 kilometer. If you're talking about area, the unit is 1 centimeter square or 1 millimeter square or 1 meter square. When talking about volume, it is 1 centimeter cube or 1 meter cube or liters. Towards the end, we will talk about how to convert from one to another, but you have to be very careful in what you're calculating, and you should put in the appropriate units. Okay, having said that, we will look at some of the important shapes that we need to be aware of. And the first one, of course, is a cube. Simple one, you must already be knowing about this. Let us say all the sides are A, the volume is A cube, and the surface area, the total surface area is 6A square. The curved surface area, sometimes they call it the curved surface area, I don't know why, but it is the lateral surface area. Lateral surface area means side surface area. Lateral means side. Okay, so this is a cube, and of course, cuboid you must have seen so many times, so we will just go through that quickly. So length, base, length, breadth, height. Volume, of course, is length into breadth into height. And the lateral surface area, let's say the total surface area is 2 into LB plus BH plus LH. The lateral surface area is just the side surface area, one side, two sides, and then there are two sides on the other side that are hidden. So it is 2 into BH plus LH. That is the lateral surface area. Cubes and cuboids are some of the easier ones. We will look at cones, cylinders, of course, I'm pretty sure you must already be aware of, just in case. So this is the height, this is the radius, the volume equals pi r square h, and the curved surface area, which is a side surface area, is 2 pi r h. Total surface area is pi r square plus, well, 2 pi r square. That is because there are two circles, one on the top and one on the bottom. The total surface area equals the side area plus 2 pi r square. So this is a cylinder, and the reason why I'm talking about cylinders right now is you will definitely see shapes like this, a cylinder on which a hemisphere is mounted, or even this, where you have two hemispheres on either side of the cylinder. Okay, now cone is something that you must have studied about in 9th standard. So when we talk about cones, we always talk about right circular cones. Right circular cones are cones where the axis makes a right angle with the base. If you have a cone like this, it is not very easy to solve that, so let us not worry about that for now, and I don't expect that to come in the examination or even study about it in the 10th standard. So in the case of a cone, this is called the slanting length, or L, and this is the radius, and this is the height or the altitude. The volume of the cone, well, let's talk about the surface area of the cone. The lateral surface area, or the curved surface area, or the slanting surface area is pi r L, where L is root of r square plus h square. R is the radius and h is the altitude or the height. The total surface area equals the side lateral area plus the area at the bottom, but there's a circle at the bottom, so pi r L plus pi r square. And the volume is 1 by 3 pi r square h. 1 by 3 pi r square h. This is the volume of a cone. You will definitely see cases where the cone is mounted on a hemisphere. The cone is mounted on a hemisphere. I've seen this question a number of times. So you would need to know how to calculate the volume separately, how to calculate the surface area separately. For example, in this case, you have the surface area of the hemisphere plus the surface area of the cone together. And same thing, the volume will be the volume of the cone and the volume of the hemisphere added together for this object. Okay, now let's make some space here because we are going to be um, discussing spheres. A sphere is a ball. I'm pretty sure you are aware of that. A sphere is basically a ball. You can call it a 3D circle if you want. It's a three-dimensional shape with a center which is inside. The sphere could be hollow, the sphere could be solid. It doesn't matter from a sphere's perspective as long as there's no opening. So the curved surface area of a sphere equals 4 pi r square, where r is the radius of the sphere. The volume of the sphere is 4 by 3 pi r cubed. So if you take half of the sphere, which is the hemisphere, as I show here, the hemisphere, the volume will be half of the sphere, which is 2 by 3 pi r cubed. The curved surface area of a hemisphere is, of course, 2 pi r square. But then there is a total surface area, which is the curved surface area plus the area of the base. The area of the base is pi r square. So area of base is pi r square. So you add those two together, you'll get 2 pi r square plus pi r square equals 3 pi r square. So now let us look at certain combinations. So here are some shapes that I have seen before, and I'm pretty sure that you will come across when you go to the 10th standard. I call this the pill shape, and I think it is called the pill shape in some textbooks. So this is basically a cylinder plus a hemisphere on both sides. A cylinder and a hemisphere on both sides. So to calculate the volume, you calculate the volume of the cylinder, and then you calculate the volume of the hemisphere separately, you add them together. If you want the surface area, you calculate the curved surface area or the lateral surface area of the cylinder, and then the surface area of the hemisphere and the surface area of this hemisphere, you add them together. So this is an example of a building where you have a cylinder and a hemisphere that is mounted on top of the cylinder. How do you find out the volume? You find out the volume of this and the volume of this separately, you add them together. However, finding the surface area can be tricky. So this is the outside surface area, you know, the value for that, which is 2 pi r square. And this is 2 pi r h, which is the outside surface area. In case, let us say the question is, hey, I want to paint the building from the outside and the inside, then you have to find out the outside surface area and the outside surface area and multiply it by 2 because that will be the same as the inside surface area in this case. You should not take into account the base surface area of the hemisphere. But in this case here, it's basically a hemisphere which is hollow. How do you find out the volume? The volume is pretty easy. It's just half the volume of a sphere. But the surface area can get very tricky because the outside surface area is 2 pi r square. Inside also, let us say, if you want to, for example, paint the inside of it, it is also another 2 pi r square. So the total surface area may be 4 pi r square, which is exactly the surface area of a volume. So here you have a cone that is mounted on a hemisphere. So the volumes are easy. The surface area is also not that difficult. You get the surface area of the cone, and you find the surface area of the outside surface area of the hemisphere. You add them together. So this diagram did not come out very well, but this is basically a cube in which a hemisphere is carved off. Hemisphere is carved off. So here, if you want to find the volume, you find the volume of the cube, you find the volume of the hemisphere, you subtract the hemisphere volume from the cube volume. Finding the surface area is slightly tricky. You get the surface area on all 4 sides, and then on the bottom and the top, you just have to find out this surface area by subtracting the area of the circle from the area of the cube surface, or the square, I mean. And then you have to add the inner surface area of the hemisphere, which is 2 pi r square. So when you go to the 10th standard, it gets very interesting because you see a lot of these combinations. If you know how to, the one thing that you have to do is to visualize the questions. If you are able to translate the questions into diagrams like this, it's a lot easier and it's a lot interesting. Practice and practice is what will get you there. But this is a good start, and it is a good refresher to make sure that you understand some of the concepts and also the areas and the volumes of the corresponding objects. So with this, we will conclude this video, and I will see you in the video which will be posted tomorrow, and that will be about statistics.